let's talk about total internal reflection. And total internal reflection basically is a consequence of the law of refraction. So if you haven't watched the video on law of refraction, I encourage you to do so before continuing on with this video. Now, if you have watched that video, then you probably recognize everything I have here because it's the same setup that I had. And just as a reminder, you can see in our diagram, theta b is greater than theta a. That's pretty straightforward. That means the sine of theta b is going to be greater than the sine of theta a. To maintain this equality, that means the index of refraction for b has to be less than the index of refraction for a. So I have light coming in from A, it approaches the interface, hits the interface, and then it's deflected quite a bit. Now, if I change the angle that it comes in, let's say I make this angle a little bit bigger, like so. Okay, now I've made it a little bit bigger. Well, now the sine, because the angle's gotten bigger, the sine is a little bit bigger. Well, to maintain the equality, this has to increase. So that means the angle theta b has to increase, so this gets a little bigger, like so. Okay, well, if I keep increasing this angle, and again, that's the angle relative to the normal, if I keep increasing it, eventually I'm going to get to a point where this angle is right along the interface. So we've got, relative to the normal, a 90-degree angle. Well, at 90 degrees, the sine of 90 is 1, so that means the right side just becomes in B. So the question becomes, well, what if we make this angle even bigger? What if we make this just a little bit bigger? Well, what's going to happen then? Well, then what is going to happen is we're going to get reflection. It's called total internal reflection. That's what's going to happen. So when the angle has gotten past that critical angle, and that's what this is right here, this formula that we've got here, this angle defines the critical angle. This situation, this formula here, defines the critical angle. And so we get sine of theta critical. This is how it's written in the content. Okay. And NA has to be greater than NB for this to be true. Okay. This defines a critical angle. If theta A is greater than the critical angle, then we get total internal reflection. If you go in a swimming pool and you go underwater and you look up, you will see total internal reflection in the from down below. You'll see it in the right at the interface between the water and the air. You'll notice that you're getting total internal reflection there. But just to back up here, so this angle where this occurs right here, okay, that angle, whatever that angle is right there, that's the critical angle. That angle there is the critical angle. We no longer have this theta b and this angle here. This right here is, this would be 90 degrees to here. And again, the sine of 90 is 1, so that's why that's disappeared and it's just become in B. So we get this relationship, which allows us to find the critical angle. And if the incoming angle is greater than that critical angle, you're going to get total internal reflection.